Alright, this is another gas problem, and when we look at this one's slightly different. You have a sample of argon gas and flexible, the volume at STP, temperature changes. Okay, so when we look at this one, we start to realize, wait a minute, we're going to change things. So let's go ahead and ID what we have. The first volume is 1.045 liters. It's at standard temperature and pressure, which means standard temperature is 0 degrees C or 273.15 K, and standard pressure is 1 atmospheres. Okay, now then the question is if the temperature changes, so we know our temperature changed to 22.34 degrees C, which is 295.49 K, and the pressure is found to be 267.2 kPa, then the question is, what's the new volume? And we're going to want it in milliliters, okay, in the container. Now, once we look at this, all right, so if there are two ways to look at it, well, first and foremost, if we're using PV equals nRT, T's changing, V's changing, and P's changing. So, PV over T is equal to NR. This is our constant. So that means that we can say P1 V1 over T1 is equal to P2 V2 over T2. So what we're looking at here is we're comparing our changing pressure, volume, and temperature. So we're not going through the ideal gas law. So we're not using the R constant. So it doesn't matter what our units are as long as they're the same. Okay. So first and foremost, I'd make my life easier. I'd go ahead and convert that to milliliters because that's what I want anyway. Temperature still has to be in Kelvin, and wait a minute, pressure is in either atmosphere or kPa. Now, you could go either way on this one, but the easiest thing is that we know that 1 atmosphere is 101.325 kPas. So rather than convert the kPas to atmosphere, then take the path of least resistance, in this case, the easier conversion. But if you want to convert the other one, you're going to get the same answer, so it really doesn't matter. Now, we're to algebra, so P1 V1 over T1 is equal to P2 V2 over T2. Now, you can go ahead and substitute in, but I'm kind of a little algebra nerdy, so I like to go ahead and solve. So I know that V2 is going to equal to P1 V1 T2 divided by T1 P2. So once I do that, the only trick is making sure I substitute in right. 101.325 kPa is my P1. My V1 is 1045 milliliters. My T2 is 295.49 K. And my T1 is 273.15 K. And my P2 is 267.2 kPa. So we'll run the numbers out, and V2 is found to be 428.68475 milliliters. And you were told to report the answer in 4 significant figures. So that would be 428.7 milliliters would be my final answer to report it. So this shows you how to use individual gas laws to get your final answer.